Good morning, students. Today we are going to study about circles. So you already know the line segment which touches the circumference of the circle is known as tangent. The line segment which touches the two ends of the circle, it is known as chord. And the line segment which begins from outside and gets extended, this is known as secant. So here we are going to study one theorem. Theorem says perpendicular is the shortest path drawn from a point. So here in this figure you can see, suppose that xy is the line segment which touches the circle at point A. From O to A, this is the radius. So at point A, we can say that it is tangent. Okay, xy acts as tangent. Now, in standard 9, you have already studied about inequalities. This point, if we are naming as C and D, from here if you will compare, you can say that OC is greater than OA. This becomes equation 1. In the same way, you can say OD is greater than OA. If you want to draw more line segment, you will come to the conclusion that OA is the shortest path drawn. And inequalities of triangle in standard 9, you know that you have studied that perpendicular is the shortest path drawn from the point. So from there we can say that since OA is the shortest path drawn, so OA is perpendicular to XY. So from here we can conclude that radius drawn on tangent is always perpendicular. Now let us discuss second theorem. Here in this diagram, you can see that PA and PB are two tangents drawn from the external point P. So here we are going to prove that PA is equals to PB. Next we are going to prove angle AOP is equals to angle BOP, and third part we are going to prove angle APO is equals to angle BBO. So what is the statement of the theorem? Theorem says tangents drawn from the external points are equal. They are equally inclined and they subtend equal angles at the center. They are equally inclined and they subtend equal angles at the center. So how are we going to prove this theorem? In triangle APO and triangle BPO, first part, can we say OA is equals to OB? How can we say OA equals to OB? Because they are the radii of same circle. So we can write here radii. Second, we can write OP is equals to OP. This is the common side. Common side. And third part we can write angle OAP is equals to angle OBP. As we have discussed in theorem 1, this is the radius and this line segment is the tangent. Radius drawn on tangent is always perpendicular. We can write reason here. Radius drawn on tangent is perpendicular. From here we can say that triangle APO is congruent to triangle BPO, and the property will be RHS, 90 degree hypotenuse and one side. So the property is RHS. Therefore from here we can conclude that AP is equals to BP by CPCT. You know that when two triangles are congruent, their corresponding sides and corresponding angles are also congruent. So here you can also conclude that angle AOP is equals to angle BOP. This is also we can write CPCT. And the third part that you can prove that angle APO is equals to angle BPO. So in this theorem we have proved that tangents drawn from the external points are equal. Whatever I have proved, I am marking it with blue marker. These two sides are equal. The angle formed in the center are equal, and the angles are equally inclined. Hope so you have understood the theorem. Now we will discuss the sums in our online class.